Welcome to episode 6 of the Midnight Developer Workshop series. The last 5 episodes gave you the full developer toolkit: CLI, Playground, AI-assisted contract generation, explorers, and wallets. Today, we're going to do something different. We're going to zoom out from tools and talk about a bigger vision: the machine-to-machine economy. Drones, rovers, actuators, sensors, all with sovereign cryptographic identities, all negotiating with each other. And then we're going to get hands-on with the proof of concept. We will register a .night domain and use it to gate a smart contract. Let's go. 4 things you will see today. 1. Why a machine-to-machine economy needs sovereign cryptographic identity. 2. How .night domains and the Midnames SDK actually work. 3. The concrete pattern for getting a smart contract behind a proven domain ownership. And 4. Explain the limitation of this proof of concept and what remains to be done to get a real machine economy. So, who is this for? 3 audiences. First, the app developers who want a concrete pattern for identity-gated interactions, a drop-in recipe you can use on your next contract. Second, robotic and IoT engineers who are thinking about device-to-device transactions and need a foundation to start from. And third, identity researchers who are curious about how digital identities land on a real chain with a real zero-knowledge primitives. If any of those is you, you are in the right place. A quick summary for anyone new. First, Midnight is a privacy-first blockchain, a Cardano partner chain built by IOG with a dual state model: public chain plus encrypted private data, secured by zero-knowledge proof. Second, it uses 2 tokens: Night for value, dust for fees. Third, the smart contract language is compact, TypeScript-like, compiles to zero-knowledge circuits. And fourth, Lace is the browser extension wallet that signs transactions and generates proof. If any of these sounds unknown, pause here and watch episode 1 through 5 first, then come back. For anyone else, let's get into the vision. Here's the vision for the future. Every drone, rover, actuator, and sensor has a sovereign cryptographic identity and negotiates with other devices through zero-knowledge proof. What that means and what it doesn't. It's not a human clicking approve on every interaction. It's not an API key shared across a fleet of 10,000 devices. It's not a central trust authority deciding who's real and who isn't. It's devices owning their own keys, owning their own names, and owning their own transactions. That's the world we are trying to build. And it's not science fiction. The cryptographic primitives exist. The chain exists. The standards are emerging. What's missing is the integration work. Let's explain 3 possible scenarios. 1. A drone marketplace. A delivery drone arrives at a warehouse, looks on available routes against other drones, proves its flight rating and safety certifications, wins a contract, and collects tokens on each successful package delivery. No logistic coordinator, no human interaction. 2. A taxi and a charger. An autonomous taxi pulls up to a roadside charger. They negotiate a per kilowatt-hour rate for this session. The taxi pays per second as charging happens, and both settle on chain. No subscription, no account, no human in the loop. 3. A sensor data market. A weather station publishes reading to a smart contract. It proves the data is timestamped in the last 5 minutes, but doesn't reveal its exact location. only the region. The user pays for useful data. All these three examples need the same primitive: an identity the device controls, a way to prove facts about that identity without oversharing, and a payment rail that works at machine frequency. Why don't we just use what we already have? 4 reasons. 1. API keys. They are issued by a central authority, revocable at any moment, leak easily, not portable across surfaces. Your device existence depends on a vendor's behavior. Second, service accounts. They are tied to a cloud provider billing account. That's not identity. That's a line item on an invoice. Third, device certificates. They're closer, but the certificate authority still decides what's real. And fourth, shared secrets. Imagine one fleet key distributed into 10,000 rovers. One leak and the entire fleet is compromised. None of this is scaled to a world of billions of autonomous agents. We need something fundamentally different. What does sovereign mean? Sovereign identity means 4 specific things. 1. The device generates its own keys. No certificate authority required. Key generation happens locally, bound to hardware where possible. Second, the device controls its own name. It's registered on a public chain, not on a DNS server someone else operates. Transfer happens on chain, not through out-of-band paperwork. Third, ownership is cryptographically provable. It's not a database lookup that can be tampered with. You prove control by signing. And fourth, identity survives the vendor. If the cloud shuts down, if the company is acquired, if the server is discontinued, the device still has its identity and can still transact with whoever is still running the chain. That's what sovereignty actually buys you. People often ask, why do machines need privacy? They're just machines. 3 reasons. 1. Unlinkability. A rover's session with the charger shouldn't be linkable to every other charger it's ever used. The movement pattern is a fingerprint. If every interaction is public and changeable, an adversary can reveal the entire operational history of a fleet. 2. Competitions. Fleet movement reveal business strategy. If I run a delivery company and every drone transaction are public, a competitor can watch my logistic in real time. That's not acceptable. And 3. Surveillance resistance. A world where every device has a public transaction history by default is a dragnet, one that treats bad actors and honest users equally. Privacy should be the default for machines exactly like we believe it should be the default for humans. Okay, that's the vision. Now, let's get concrete. What are the primitives we actually have on Midnight today? How do they compose? And crucially, where does the honest story about zero knowledge stop and start? Let's start with the term you will see a lot, DID, Decentralized Identifier. A DID is a string you control via a key pair, which results to a public record without asking any central authority. That's the definition. 3 pieces, left to right on the diagram. The DID string itself points to a DID document, which holds public keys and service endpoints. And you prove you control the DID by signing something with the corresponding private key. That's the whole concept. Every decentralized naming system you have heard of, ENS, DIDs on Solana, unstoppable domains, and yes, also midnames with the domains .night, implements this same pattern with different specifics. So how is a .night domain different from a regular .com domain? It's just DNS with the trust model flipped. First, authority. A DNS is only records, but an on-chain naming system is a smart contract on a public chain. No gatekeeper who can be pressured or acquired. Second, censorship. A DNS controller can revoke your DNS name. On-chain, only the key holder can transfer, period. Third, transfer. DNS transfers are out-of-band paperwork. On-chain transfer are a transaction that settles in seconds. And fourth, verification. With DNS, you trust whatever resolves your query. On-chain, anyone can read the chain directly and verify themselves. Same concept, different trust assumptions. That's the whole argument. So let's define .night domains concretely. What is it? A human readable name, for example, alice.night or rover42.night. All of them map to a wallet address on Midnight. Where does it live? On-chain, in a registry contract, resolvable via an indexer. Who controls it? The wallet whose public key matches the domain's registered target. I will define that more precisely in a moment. But conceptually, it's whoever can sign with the key the domain points to. Why does it matter? It's the first production-grade sovereign naming primitive on Midnight, built from day one to plug into the apps. The Midnames team shipped a TypeScript SDK, so using it is as simple as using an npm install. Here are the three-layer architecture. Top row, left to right. Registry, indexer, SDK. The registry is the smart contract on-chain. It's the source of truth, which domain points to which address. Writes go through it. Registrations, profile updates, transfers. Those are on-chain transactions. The indexer watches chain events, builds a searchable database, and serves fast lookup over HTTP. Reads go through the indexer. The SDK, Midnames SDK, is a TypeScript library your DApp imports. It talks to the indexer for reads and helps you construct transactions for writes. Your app never talks directly to either the registry or the indexer. The SDK abstracts both. This is a standard shape for naming system. Writes are on-chain and authoritative. Reads are off-chain and fast. The separation is what makes it practical to use. What do you actually get back when you resolve a domain? Here's the shape. The domain string itself, normalized, the target and the owner, and a profile object with fields like name, bio, the avatar URL, Twitter, GitHub, website, etc. Notice something here. Everything in this record is public, on-chain. Anyone who looks up alice.night sees all of this. Design your user experience around that. Don't put anything in that profile you wouldn't put on a business card or a LinkedIn page. If you need private data, you store it somewhere else. 4 steps flow for what happens when a user types a domain into your app. Step 1. The user types something like alice.night. Step 2. The SDK normalizes the domain to lower cases and appends .night if it's missing. Step 3. That's an HTTP call to the indexer, which looks for the domain. Step 4. The indexer returns the full profile. That's a path. It's fast, typically under 100 milliseconds. And notice, no wallet involved yet. You can resolve any domain without a connected wallet. The wallet only enters the picture when we verify ownership. How does the SDK verify that the connected wallet actually controls a domain? Let's read the code. Line 1. Grab the wallet's public key. That's what Lace exposes through the DApp connector API. Line 2. Grab the domain's target. That's also a public key, the one the domain points to on-chain. Line 3 and 4. Decode both keys. Line 5. Compare the keys, and if they match, return true. That's the whole check. 6 lines. No circuit, no proof, no server. Just a comparison in the browser. And that simplicity is exactly what brings us to the next slide. 4 pieces of the great path for machine scale identity. First, zero-knowledge set membership. A rover should be able to prove in zero-knowledge that it controls some key register and a pattern like flip.night without revealing which specific key. The charger doesn't need to know this is rover 42 versus rover 43. It needs to know this is a legitimate fleet member. Second, selective disclosure. The device proves one field of a credential without leaking the rest of the record. Classic zero-knowledge pattern directly applicable here. Third, unlinkable sessions. Each check-in generates a fresh nullifier, so the same device transaction can't be chained together. Privacy over time, not just per transaction. Fourth, and this is important, the stack already supports all of this. Compact compiles to zero-knowledge circuits. Midnight has the cryptographic primitives. The upgrade to tomorrow's zero-knowledge identity is at the SDK level, not the chain level change. That's encouraging. Here's how the pieces compose inside your app. Lace gives you the user's shielded public key and signs transactions. Your app takes that key, calls the Midnames SDK to get the profile, compares the keys, and only if the verification passes, call the counter compact contract, which comes with the Ada Labs starter template. Notice the composition. The contract knows nothing about identity. The identity check is purely front-end. That means you can drop this pattern in front of any compact contract you like without changing the contract. Let me summarize the deep dive in 1 sentence. Any machine-to-machine system needs 3 primitives. First, identity. We have this today in .night domains. Second, selective disclosure. Zero-knowledge proof that reveal only what the interaction requires. We have this in compact circuits, but we haven't wired that into identity yet. That's the upgrade path. Third, gated interactions. Contracts succeed only when the identity proof validates. Midnight has all 3 as composable pieces. That's what makes it interesting for this class of problem. Hands-on time. Here's the plan for the hands-on. 2 live demos. Demo 1. I will register 4 domains on midnight.domains. For the first domain, I will show you how to include its own avatar, bio, email, and others. Demo 2. I will show the functionality of the repo midnight-starter-midnames, which is a reference app that wires midnames, Midnight Network Decentralized Identity System, into a standard counter smart contract. Fork from the Ada Labs Midnight Starter templates, it adds a conference room page where only verified .night domains owners can enter. The app resolves the domain via Midnames SDK, compares the connected wallet public key against the domain's on-chain target, and only then unlocks the on-chain increment code. The counter becomes the room's participant number, and each member's avatar, name, and bio is pulled from their domain profile. It's a small demo, but it exercises the full flow. All the moving pieces a real identity-aware Midnight app needs. 4 things you need set up. Lace wallet install and unlock on pre-prod. some tested nights and dusts. You can grab those from the pre-prod faucet. Note 22 or newer, and PNPM 10 or newer, and a code editor open. We're going to read files live. If you follow episode 5 and already have lays set up with testnet functs, you can skip the faucet setup. If this is your first time, pause here and get lays working before continuing. Nothing that follows work without it. Okay, let's start with demo 1. In this slide, you can see a brief summary of what we are going to do. Okay, let's switch to the terminal. 4 of my .night domains use the same lace wallet account. That simplicity is chosen for this demo, but it has a direct machine-to-machine parallel. On the left, for this demo, one wallet signs 4 check-ins. The counter takes 0 to 4. On the right, the machine-to-machine parallel is a fleet operator hardware wallet controlling many devices' identities. Rover 1.9 through Rover 4.9, all signed by the fleet's hardware key. Same pattern. The room doesn't care how many identities one wallet holds. It only cares that the signer controls the domain's target. Keep this in mind when you see the counter ticks 4 times. It's 4 independent identities under one signer. Quick reminder of the privacy boundary. Public on-chain. The domain string, the target public key, the owner address, and all the profile metadata fields. For all 4 domains, everyone can read it. Private, known only to me. The wallet seed phrase, shielded token balance, private contract state, and my shielded transaction history. The profile is your public-facing identity. Don't put anything there you wouldn't put on a business card. Okay, let's start with the second demo. In this slide, you can see a brief summary of what we are about to do. Okay, let's switch to the terminal. Let's compare what you just saw with where this goes. Today, in this demo, one operator, one lace wallet, 4 human names, Ivan, angpt, Erick, taina. Each resolve, each verify, each check in. Counter 0 to 4. 4 distinct profiles in the guest book. Tomorrow, in the machine-to-machine case, one fleet operator, one hardware wallet, 4 devices names, rover 1 through rover 4, 4 autonomous check-in, no human clicking sign-in, swap humans for devices, swap lace for a headless signer with hardware root keys, swap increment for a real negotiation circuit. The identity layer doesn't change. That is why this proof of concept matters. It's not about human guestbooks. It's a proof of concept for a future machine workload. So this is the summary. 4 resources to take with you. First, midnight.domains to register your .night. Second, the midnames starter templates. Started with the fork from the Edalat's midnight starter template. Third, the official midnight documentation. And fourth, episode 1 through 5 of this series for the rest of the developer toolkit. And remember, this is just the first step towards a real machine-to-machine economy. The rest of the stack, machine wallets, credentials, negotiation circuits, standard, governance, reputation, oracles, that's where the real work is. So go register a .9, fork the repo, break things, fix things, and extend things. Leave a comment with what you built. I want to see it. Thanks for watching. See you on chain.